Hello guys, welcome to the channel. Today we are going to discuss about the classless IP addressing. Then we'll discuss the CIDR notation and then slash notation. Now, before this, we have discussed about the classful addressing where there was the concept of uh, classes availables. So, what are the drawbacks of that classes available with us with the IP version 4? That we have to first discuss, and then after we'll start with the classless addressing. So, if you talked about the classless IP addressing, classful IP addressing, guys, we can say in the class A, class B, and class C. Class D and class E are not going to be used for the user's purpose. But if we use these three classes for the user's purpose, the maximum IP addresses can be going to be best. Because if we talked about, let's say, class A, the subnet, the mask with 255.0.0.0 can support up to 167777214 addresses. That is, which is all 128 different blocks. So this is going to be a 50% of total address space. Okay. In class B, it is going to be again default mask is 255.255.0.0 and it supports 65,534 addresses, which of what 16,384 different blocks. So this is what the very huge number. And like a C also, we have only 256 or 254 valid IP addresses are available with us with the 2097152 blocks are available. So if you talked about the classful addressing, so here there are the plenty of addresses are going to be west. But because but the user requirement is very typical and very less we can say. Let's say, but what happened if someone required 2000 and 1000 addresses? So if you go with the solution to solve these problems, we can say solution number one way is to address solve this situation is what, provide the person with the class B address. So if I go with the class B, if I go with the class B for the 2000 and 1000 addresses, so here there will be a plenty of addresses will be west. So that can be insufficient use of address space will be there because I required only 1000 addresses, and if I choose any of the block where this number of 65,000 addresses are available. So if I minus this 1000 from the 65,000 addresses, so rest of the IP address going to best. Solution number two, another possible way is to provide the multiple classes of C networks. For this solution, for this problem statement, I can use the multiple classes of the C class. Let's say network that is increase the router traffic. If I use, let's say, if I want thousands IP addresses, so 254 into, let's say, 5 required. So 5 times I need to maintain different networks. So maintaining a different networks also very difficult, guys. So it will increase the router table entries. So this solution is not that much good solution. Then solution number 3 is what, to reduce the wastage of IP address in a block. We use the subnetting or supernetting. What we have discussed, subnetting and supernetting on the basis of the requirement. We can design the, we can increase or decrease the size of the net IDs, but subnetting size is also fixed. So we can have only a fixed size of subnetting, so we cannot have variable, so the requirement cannot be satisfied. So here lack of internal address flexibility. So in order to give the solution to this problem, what we have, different solutions are available, but the solutions are very much not good for this particular problem statement. There insufficient use of address space will be there, increasing of router tables entries will be there, and lack of internal address flexibility will be there. But then what is the solution? The solution can be one. Solution can be one, and that solution is what? Although the long range solution already has been devised and it is called as IP version 6. But if you go with the IP version 6, that is 2 to the power 128 number, it is very huge number. Again, there will be a problem. So this IP version 6 solution is not that much good solution for us, guys. Okay, so can we do better than this to solve this problem with the available of addressing scheme? Yes, and that answer is what, CIDR notation. And that answer is what, CIDR notation. In the CIDR notation, this mechanism is what, it is improved IP address system over the classful one. In this scheme, the variable length blocks are used not belongs to any class. There is no funda of any classes available. Class A, B, C, D, E. There is no classes. Totally freedom from the classes. It makes the allocation of IP addresses more efficiently as per the requirement, I can say. Then it replaces the older classful addressing system based on the classes. So it is going to be improved one. So it has replaced this one. Then it is also commonly called as CIDR notation. Then here, what is new in this particular CIDR notation? There is a variable length blocks are available. In the classless addressing, the whole address space is divided into variable length block. So typically, if you go with the classful, so we can have 2 to the power 24, 2 to the power 16, 2 to the power 8. These are the blocks where available. But here, theoretically, we can say we can have a block of 0, 20, 21, 22, 32 addresses. So there will be a sequence of addresses. As per the requirement, we can do. Then again, more points about the CIDR notation or CIDR block. When the user asks a specific number of IP addresses, the CIDR notation is going to be used. The CIDR dynamically assign the block of IP addresses based on the certain rules. There are 3 rules, guys. We are going to discuss that 3 rules. What are the 3 rules are available? And this block contains the required number of IP addresses as demanded by the user. This is very, very important, guys. As per the requirement of the user, the size of the block can be vary. This is very, very important. And this block of IP address is called as CIDR block. So here, the blocks can be called as the CIDR block on the basis of what user requirement, whatever the size will be there, that will be called as what CIDR blocks. Then here, what are the certain rules to chalk out the CIDR block? So there are 3 rules actually. Rule number 1, if you go with the rule number 1, all the IP addresses in CIDR block must be continuous, This is very important, guys. Let's say if CIDR is /17, generally CIDR notation is denoted by /value, and whatever the value is there, that number of bit will be contiguously 1. So if I have in the /17, then these are what 8 plus 8 was 16 plus 1. This is what 17 total number. This is what the 17 total number, and rest of the things are what off. These 17 are on, and rest of the things are what off, and this is what valid. This is what valid. But if you talked about, let's say 8 times once, then 6 times 0, 6 times 1, then 0 0, and then 1, this is not going to be valid. So here our first rule is what the addresses in the CIDR block must be contiguous, because we have to calculate it. We need to calculate the subnet portion and the subnet mask, so that's supposed to be contiguous. Rule number 2, guys, this rule number 2 is very also important. The size of the block must be representable of power of 2. Whatever the value we are going to calculate, that was supposed to be power of 2, power of, let's say, 2 to the power 1, to the power 2, to the power 3, to the power 4. This is supposed to be in the form of what, let's say, only to the power some values. The size of the block in the total number addresses contained the blocks. The size of any CIDR block will always be in the form of 2 to the power 1, 2 to the power 3, 2 to the power 4, and so on. So this is very important, guys. Then if the block size is 2 to the power 5, so how much address will get? 2 to the power 5 is what, a 32, and the host ID will contain the 5 bits, and the network ID will contain the what, a 32 minus 5, that is what, 27 bit. So 27 bit will be contiguously on, and rest of the things what, 5 bit 1, 2, 3, 4, and 5, this will be off. This is what right side, and left side will be all 1. Left side will be all 1. So this is rule number 2, where the value is supposed to be 2 to the power 4. And rule number 3 is what? First, IP address of the block must be divisible by size of the block. And this is what, again, rule number 3, that is very important, guys, that IP address of the block must be divisible by any size of the block. That there's supposed to be a even divisibility formula. Let's say 16, 32, let's say 64, etc., etc. Okay, let's take an example of this. Certain rules are there. Sorry, let's say there is example. Check whether 100.1.2.32 to 100.1.2.47 is a valid IP block or not. So we have to check this IP address range is given, whether we have to check whether this is valid or not. Then apply the rules. All the addresses are contiguous. Yes, obviously all the addresses are contiguous. That is 31, 33, 34, 34 to 47. Okay. Then apply the rule number 2. Total number of addresses in the block, let's say 16. That is what, 2 to the power 4. So first IP address is what we can say, the 100.1.2. Let's say 32. This is what, 32. So this is what the first address. So we have applied the second rule. It is also passed. Then apply the third rule. Since the host ID will contain the last 4 digits, a lot 4 bits. Okay, because we have the power up to the power of this value. So the 4 digits of the right hand side will be 0. And all the least significant 4 bit are 0. Okay. Hence, the first IP address is evenly divisible by size of the block. So here, all 3 rules are applicable and applied over here. So here we can say this is what the valid IP address. All the 3 rules are applied over here by the blocks. Hence, This valid IP address, this IP address is what the valid IP address. So in this way, we can apply the rules over that particular slash value and the CIDR value, and we can check whether that is valid or not. If you talked about this particular example, that is 32 onwards, by adding the 32 again, we'll get the up to by adding 16, we get the 47 to 48 addresses. So that will be the answer. Now let's talk about the some two-level addressing the CIDR notation. There are two-level addressing, as we already aware about the host ID and net ID available in the classes. Let's say if in a classful addressing there are two-level addressing was provided by dividing this address space into certain mechanism, and that mechanism what was net ID and the host ID, where net ID represent the network IDs and host ID represent the host IDs to represent the host. But the same idea is applied over here, but the nomenclature is different. In the classless addressing, we when an organization is granted a block of addresses, the block is actually divided into two parts, and that name is what prefix and the suffix. Here we go with the classful addressing. So it was the network ID, and network ID will be called as a prefix. And here, if you talked about the host ID, it will be rectified. It will be announced as what the suffix. So this is what the concept is similar with that classful addressing and the classless addressing, but the nomenclature is different. In the prefix plays the same role, add a net ID and host ID, as I told you guys. In the classful addressing, the length of the net ID, that is value of n, depends on the class of the address, and it can be only 8, 16, and 34, 24. This is what the fix, I can say. This is fix. This is fix. But if talked about the classless addressing, the length of the prefix n depends upon the size of the block, and it can be 0, 1, 2, 3 up to 32. So it is variable, I can say. It is variable, not fixed. Okay. In the classless addressing, the value of n is referred to as the prefix length, and the value of n minus 2, that is 32 minus n, is the called as suffix length. So if you minus all the value, let's say prefix will be what n value, and if you minus this n value from the total space, that is what 32 minus n will got the suffix value. So what is here? Suffix is what the host ID, and prefix is what the net ID, guys. So this is similar funda with the earlier one. Then we have a slash notation in the CIDR concept. In the slash notation, what we have extra discussed so far, the two-level addressing, the classful addressing, and the classless addressing. So here also, just go with the standard definition, guys. The slash notation is the compact way to show or write a IP version for subnet mask. This is very standard. So whatever the value is available with the slash notation, that will be contiguously on as the left-hand side, guys, and will be denoted as what the slash notation, as good as it is what the subnet mask. When we use the slash notation, you write the IP address forward slash this one and subnet mask number. So whatever, let's say this value, and this n will be the number of from 1 to 32. This will be the value. If you go with the more details about slash notation, the net ID length in a classful addressing or the prefix length in the classless addressing plays very important role when we need to extract the information. So if we want to solve the numericals that we are discussing right now, we'll discuss later on. So to extract the first address, block address, and last address, this slash notation is going to be very important. Then, however, there is a differences in the classful and classless addressing. Let's say in the classful addressing, the net ID is inherited from the addresses. It gives an address. We know that the classes of the addresses that allow to find the net ID length of 8, 16, 24, this is fixed. We have discussed, but in the classless, what we have variable length, where we have a prefix and where we have a suffix. So this is what the definition, guys, and this definition is very simple. This is as good as one subnet mask. But here, if you go to the syntax, so the very first byte 1, then dot, then byte 2, then byte 3, then byte 4, slash. This is what very important, slash. This is what the forward slash, and the value is associated with that one will be indicated what the slash notation, and that weightage will be called as, let's say, that number of bits will be on. Okay, then and then notation is informally referred to as a slash notation, and the class addresses in the classless addressing can be then be represented as shown in figure as like this. Okay, then check how it is going to be applied over the particular what we can say, the numericals and the tables. So if you go with this particular table, so this is what the standard table. I have selected few of the slash notation over here. There are slash notations start from the 0 to the 32. But I have taken some few very example. Let's say slash 0 value, all 0 will be there. This is what the default. Subnet mask will be 0000000 and 255 255 255, which is belongs to the class. If you go up down, if you go to upward direction, if I take the /1 is notation, so only one bit from the left hand side will be 1 and rest of the things will be 0. So it will be 128.0.0. Let's say, or 128.255.25 0.0.0. This will be the subnet mask. That is 128.0.0.0, which also belongs to the class A. If you go with the upper side, let's say if you take any example from the class B, 14/14, so this will be 8. 8 plus, let's say, 6 will be 14. So contiguous 14 bits are what? On, and rest of the things will be off. So what we can say, 255.252.0.0, this belongs to the class B. If you go upper side, let's say 32, 31, 32, let's say 32, all are 1. So this is what the standard. So 255, 255, 255, 255, all time the class, it belongs to class C. Okay, so this is what the notation where there are plain tables are available. On the basis of this, whatever the value of the CIDR notation of the slash notation, on the basis of that, we have to calculate the contiguous number of ones from the left hand side to the right hand side, and rest of the right hand side bits will be indicating to the host guys. Then let's apply how this is going to be work for the particular any numericals. Let's take an example. An address 12.23.24.78./8. So if you go with the /8 value, this is going to be what the what we can say the fix, and which is what the class A guys is what the class A. If you go with the class A subnet mask 255.0.0.0, this will be the default subnet mask. This has the 8 ones, only 8 ones, and the 24 zeros. 1, 2, 3, 4, 5, 6, 7, 8. This will be 1. And rest of the thing 0 to 0 24 times. 0 to 24 times will be 0. This is what the class A. Then if you go with this address 130.11.232.156./16. See if you get from these examples, we have 16 number of ones. That is what? On, and 16 number of what? Off. 16 number of off. So this is what the example. Second will be if you have any address 167.199.170.82/27. So if it gives the class 27, so we have to look at the value 27. So this will be 8 plus 8 plus rest 24. 24 plus 3 is also 27. So 27, it is what? The 255.255.255.224. This will be the subnet mask. Has 27 ones, and less the 5 will be 0. So this is what another examples we have chalked out for this calculation. Now let's take how that information is going to be extracted for the specific purpose. Let's take here extracting the block information. Which type of information is going to be extracted? Extracting the block information and the value of slash notation CIDR that contains all the information where we need required about, let's say, number of addresses, the first address and the last address. So here on the basis of this slash notation, we can find out these particular things: number of blocks, first address and last address. What is the formula of that? So number of blocks, the first number of blocks, let's say, can be found n is equal to the power 32 minus n. By using this formula, we can get a number of addresses and number of blocks over here. Okay, so where n is the prefix length and n is the number of address in the block. Then how to calculate first address? So there is a formula. Let's say in the block can be found by ANDing, and this is what AND operation, the address with the address mask. So whatever the mask is available with us earlier, that need to be ANDed. And AND operation is going to be there with the addresses, and we'll get the first address. We'll take example. And the last address is what? This is going to be only a OR operation. This is going to be a OR operation. In the block can be found by either adding the first address with the number of addresses or directly by ORing the address with the complement of, that is not operation of the network mask. So we have to take the network mask first of all, and the actual address, and the operation is what? The OR operation. We'll get the last address. Let's work out how this is going to be applied. So let's say simple example, guys. So here there is example. An example, let's say, consider one of the address in the block, that is 167.199.170.82/27. So this is very important. Whenever there is a value given after the slash, forward slash, and that value need to be consideration for the solving any numerical. So here the value of n is what? 27, as we discussed the formula. Hence 27 contiguous leftmost bit will be on, and this side will be on, and rest of the thing, let's say 27 plus 5 will be right side will be off. So how it is going to be calculated? Let's say how then what is the total number of addresses in the network? Let's say 2 to the power 32 minus n. So 2 to the power 32 minus 27 is what? The 2 to the power 5. So 32 addresses will be there. 32 addresses will be there in one particular block. Then calculate the first address. The first address we can calculate on the basis of the rule which is available with us, and that's what the AND operation. How it is going to happen? Let's say convert this address into binary. Whatever the address, 167, this value 167, second value is 199, guys, third value is what? The 170, and fourth value is what? 82. And after that, take the default subnet mask first of all, and then what is the value of this slash notation, that many number of bit will be on. So here 27 bit will be on, 27 bit will be on, and rest of the things will be 0. Then what to do? We have to apply the AND operation. What is AND operation, guys? 1 1 1 1 1 1. Wherever there is both 1, only put up 1. Rest of the things only either 1 or 0 will be put at 0 0 0. Okay, then 1 1 1, then last will be also 1. So this will be the answer. Then again apply to the same one, and same like to the others. So whatever there is the answer, let's say last we applied the last octet 0 0 0 1 0 0 0 0 0, only here 1 1 is there common, so we have applied the 1 1. So what we get the address? What we get the address? 167.199.170.64. This will be the first address of that block, whatever the block is available. And by adding this block 60, let's say my blocks will be 0 to 31, that will be 32 to 63, next will be 64 onwards. So such kind of 32 addresses will be get. And what we have selected? We have selected one block which is of what? Starting with the 64 address. Then how to calculate the last address? So what is the funda of the last address? Their operation will be OR. So what to take? Take the as it is address available with us in the binary. Then take the network mask, which is what? The reverse of the earlier mask. It is what the AND not operation or complement operation that we have discussed earlier. Network mask, इसको हमें कहीं ना कहीं रिवर्स लेना है. तो रिवर्स लेने के बाद क्या करना है? अभी उसके बाद लास्ट एड्रेस के लिए हमें सेम ऑपरेशन और ऑपरेशन के लिए 0 1 1 1 1, wherever there is one term is there, so that value will be 1. So if you do this one, so we got 167.199.170.95. So this is what this will be the last address of that block, guys. Okay, of that block. I'm not saying the entire block. It's only that particular block specific. So here what we have to do, only the AND operation, and what the second is what? OR operation. While taking the OR operation, we have to take the complement of the address mask. Complement of the address mask, and that will be find out. Then let's apply this is on the decimal numbers, guys. I hope this video is very lengthy, but it is completely all the information going to be in a particular single video. Consider one of the address in the block 17.63.110.114/24. अभी यहाँ पर हमने /24 की वैल्यू ली है, तो /24 के हिसाब से क्या करेंगे हम? 24 नंबर ऑफ बिट विल बी ऑन कंटिन्यूअस, लेफ्ट मोस्ट बिट कंटिन्यूअसली ऑन करेंगे, और राइट मोस्ट के जो 8 बिट्स है उसको ऑफ करेंगे. तो उसका कैसे फंड आउट देखो, आप वर्कआउट करते हैं. तो उसके लिए सबनेट मास्क हमने ले लिया, डिफॉल्ट सबनेट मास्क. क्लास सी का एड्रेस हमें यहाँ पर अगर 24 है तो क्लास सी का एड्रेस आएंगे, लेकिन क्लास का फंडा यहाँ पर है नहीं. हमारे पास क्या है? 24 नंबर ऑफ हमने ऑन कर दिए, तो इसके हिसाब से 255.255.255.0 यहाँ पर इतना सबनेट मास्क निकल रहा है. देन द नंबर ऑफ एड्रेस इन द ब्लॉक, इसके लिए कैलकुलेट करने के लिए क्या करेंगे? 2 to the power 32 लेंगे. सो 2 to the power 32 minus 24. 24 क्यों आया? स्लैश नोटेशन की वैल्यू है, तो उसके हिसाब से कितना आता है? 2 to the power 8. 256 एक ब्लॉक में इतने एड्रेस आएंगे, 256. अभी फर्स्ट एड्रेस उस ब्लॉक का क्या होगा? तो सबसे पहले हम एड्रेस ले लेते हैं एज इट इज 17.63.110.114. इसके हिसाब से उसके बाद सबनेट मास्क ले लेते हैं जो हमने कैलकुलेट किया है एज पर एज द /24 एज अ नंबर. एज इट इज नंबर कैलकुलेट करने के बाद 255 मतलब क्या? ऑल 0 ऑल 1 है. ऑल 1 में से हमको एड्रेस माइनस करना है, वर्कआउट करना है. तो 17, तो ऑल 1 है तो 17 है, बाकी एज इट इज 17 आ जाएंगे. अगर प्रीवियसली बाइनरी के ऊपर अप्लाई करेंगे तो सेम 255 और 63 के बीच में 63 आएगा एज इट इज. और लास्ट वाला ये 0 है, बाकी का एड्रेस एज इट इज है, मतलब ये है जितने नंबर ऑफ वंस है उसके हिसाब से बाकी 0 है. तो जहां जहां 1 है उसकी वैल्यू उतनी आएंगे, 0 है तो सारी की सारी वैल्यू आएंगी 0. तो फर्स्ट एड्रेस विल बी 17.63.110.110, and the last address will be, to calculate the last address, what we have OR operation. How to apply? Let's say take as it is address, then network mask, which is what? The reverse. of the first one because we are taking complement of this address. So 0.0.0.255. Then do the operation is what? The OR operation. So 17 or 0. There is 1 wherever there is 1, so that will be as it is value. So 17 as it is आएगा, 63 और 0, 63 as it is आएगा, 110 और 0, उसकी वैल्यू भी 110 आएंगी. देन उसके बाद जो लास्ट वाला है यहाँ पर 255 है, तो 255 इसमें से अगर हम कोई भी ऑपरेशन करेंगे ऊपर वाला तो उसके हिसाब से एज इट इज जो वैल्यू है और ऑपरेशन, तो और ऑपरेशन में क्या है, सभी 1 है, सभी की वैल्यू क्या आएंगे 111. तो हमारे पास लास्ट एड्रेस जो वर्कआउट होने वाला है जो है 17.63.110.255. This will be lost address because we have taken the size of the block is what? 256, which is starting address is what? .0 and last will be 255. So by adding this, we'll get the 256 addresses in one block with this particular CIDR notation, guys. I hope guys this video is going to be liked by you. और यहाँ पर हमने CIDR नोटेशन के बारे में पूरा थरोली स्टडी किया हुआ है, जिसमें हमने क्लासफुल के क्या ड्रॉबैक थे, उसको सॉल्व करने के लिए क्या क्या सोल्यूशन CIDR दे सकता है, स्लैश नोटेशंस क्या है, टू लेवल एड्रेसिंग क्या है, ये सारी चीजें हमने यहाँ पर डिस्कस की है. थैंक यू सो मच.